Let's start by looking at this rectangle. If I was going to find the area of this rectangle, I know that the area, or sometimes shown as A on a formula sheet, means that the area for this rectangle is area equals length times the width. So if I look at this rectangle, I can see that I have a length of 4. I have 4 units, 1, 2, 3, 4, and I have a width, or how wide it is, of 8. I have 1, 2, 3, 4, 5, 6, 7, 8 units. So to find the area, I can do length times width, or 4 times 8. Well, 4 times 8 gives me 32. So the area of this rectangle is 32 units squared. Alright, so let's say I was going to try and take the area of a square. Well, the area of a square is the same as a rectangle, because all squares are rectangles. So the area would still be length times the width. The difference is that on a square, the length and the width are both the same. On this square, I can see that my length is 4 and my width is 4. So then I would plug that in. Area equals 4 times 4, or length times width, and then I can find the area of my square. Well, another way of writing 4 times 4 would be 4 squared. So this exponent of 2 tells me that I'm going to take this base of 4 and multiply it by itself. That is what squared means. So 4 squared is really just 4 times 4. Well, 4 times 4 gives me 16. So this is really, the area of the square is 16 units squared. So what does that mean? Well, that means that 16 is a perfect square. So 16 is a perfect square, and we know that because of this model here. We can see that the length times the width of this square, 4 times 4, the sides are equal, gives us an area of 16. This also tells us that the square root of 16 is 4. And we can say that because the square root is the opposite of squaring something. So since 4 squared gives us 16, we know the square root of 16 is 4. So a perfect square is a number that can be made by multiplying a whole number by itself. It's when you take a whole number and you find the square root and you get an integer, you get another whole number. You're looking for a number times itself that will give you the original term. That is a perfect square. Alright, so let's look at this here. So I can see I have this same square that I had before, and we know the area of that was 16. So one way I can do that is count all these squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or what we did earlier, the length times the width. So we know this is 16, or the same thing as 4 squared. Alright, so for square roots, you'll see this symbol here. It looks like this. And this symbol is called a radical. You might have heard of radical before, but you're probably thinking of surfers saying, radical, dude. Alright, but this is in math. Mathematicians are using this way before surfers. This is called a radical. Alright, so whenever you see this radical in math, this means it's a square root. So if I was going to take the square root of 16, well, the square root of 16 is 4. Because 4 times 4 will give me 16. A radical is the opposite of squaring something. So let's look at another example. Down here I have a chessboard. Alright, so a chessboard, we got to find the area of, well, I can see on the sides here it's numbered 1 through 8. So I see this is an 8, and I see this is a square. So a chessboard is a square, so I know it's 8 times 8, the length times the width. So length times the width, 8 times 8, gives me 64. So the area of this square would be 64. And 64 is a perfect square because 8 squared, or 8 times 8, gives me 64. If I was looking for the square root of 64, that would give me 8. So anything when you see this radical dude, anything under it, it tells you to do the square root to find what number times itself will give you that number. So in this example, 8 squared, or 8 times 8, will give us 64. So the square root of 64 is 8. Alright, so let's look at some perfect squares, some examples. Alright, so this first one here, I can see it's a 1 unit by 1 unit square. So that would be 1 times 1, or 1 squared, which gives us 1. My next example, I have a 2 by 2 square. 1, 2, 1, 2. 2 times 2, or 2 squared, gives me 4. So 4 is a perfect square. On my next example, I have a 3 by 3. 3 times 3, or 3 squared, gives me 9. So 9 is a perfect square. My next example, I have a 4 by 4, or 4 squared, which we already did, which was 16. So 16 is a perfect square. On this green one, I have a 5 by 5 square. 5 times 5, or 5 squared, gives me 25. So 25 is a perfect square. And on this last example, I have a 6 times 6. 6 times 6, or 6 squared, gives me 36. So 36 is a perfect square. All of these are perfect squares. And we can keep going on and on forever and ever and ever and try and figure out more perfect squares. But the key takeaway here is a perfect square is any whole number times itself. So 6 times 6. 6 times itself gave us 36. So 36 is a perfect square. And if we were looking for the square root, and we were going to put this under a radical, if I was looking for the square root of 36, I'm trying to figure out what number did I square root, or what number did I square to get this? What number did I times by itself to get 36? Well, I know that is 6. So the square root of 36 would equal 6. So those are perfect squares. All right, so here's some more examples of perfect squares and how you can see them. So let's say I have 1 squared. Well, that's 1 times 1. That gives me 1. And the opposite of that is this radical, or this square root. The square root of 1 is 1. 8 squared, or 8 times 8, would give me 64. The opposite of squaring something is the square root, this radical sign. So the square root of 64 would give me 8. 3 squared is 3 times 3, which is 9. And the opposite of squaring something is square root, so the square root of 9 would give me 3. 13 squared, or 13 times 13, would give me 169. And then I can take the square root of 169 and get me back to that 13. So squaring and taking the square root are opposites of each other. And this sign that represents the square root is called a radical. Alright, so now that we talked about perfect squares, what I want you to do is pause the video, look at all these numbers on here, and I want you to circle all the perfect squares. Think to yourself, which one of these are perfect squares? Remember, if you can't think of what number times itself gives you these numbers, you can always use your calculator. Here's the Desmos calculator that we were using in class, and if you're looking at the Desmos calculator, here is our radical sign right here. That radical sign tells us the square root, right? So I can click that radical sign and then put a number in. So let's say, let's try 25, because we already did 25. The radical sign 25 gave me 5. So I know 25 is a perfect square because it gave me a whole number, and 5 times 5 will give me 25. Let's say I did the square root of 30. Well, the square root of 30 gives me a big long decimal. It's not a whole number, so I know that this is not a perfect square. All right, so pause the video, see if you can figure out which one of these are perfect squares. There could be more than one answer, and there are multiple answers. All right, here are the answers. How'd you do? So these are all perfect squares, all the ones circled in red. And the reason for that is when we took the square root, we got a nice whole number. So like the square root of 144 is 12. The square root of 81 is 9. The square root of 100 is 10. The square root of 169 is 13. The square root of 121 is 11. And the square root of 400 is 20. So all of these are perfect squares. The ones that are left are not perfect squares, because if we put these in our calculator, we would not get a whole number that could multiply by itself. So for example, if I did square root of 200 here, of 200, that will give me 14.14213562. So that's not a whole number that I can multiply by itself to get 200. So that would not be a perfect square. Alright, while we're talking about square roots and radicals, there's some other things you need to know. So when you see this radical sign, that's just a regular square root sign, right? So if I was going to put that in my Desmos, I could hit radical and then 9, and I see that it gives me 3 as my answer, because the square root of 9 is 3, because 3 times 3 gives me 9. Alright, but now on this one, I have a negative sign in front of it. So that negative sign in front means that it wants to take, this means it will be negative 3. That negative sign comes down with it. And we can put that in our calculator, just like how we did before with that one. So if I clear this out and I hit negative square root 9, I can see it gives me negative 3. What you don't want to do, and where some people make mistakes, is they put the square root sign and then the negative sign inside of it, and then put 9. If you do that, you'll get this called undefined, because you can't have a negative underneath the square root sign. Underneath the radical, you cannot have a negative. All right, so whenever you see this, make sure you keep that negative on the outside of the radical sign, and you'll get the right answer. And it's just negative 3. They're looking for the negative square root of 9, and the negative square root of 9 is negative 3. All right, there's also this little symbol here that you may or may have not seen before. This symbol is called the plus or minus symbol. So literally it means plus or minus. All right, so what this means is they're looking for two answers. They're looking for the positive square root of 9 and the negative square root of 9. So the positive square root of 9 I know is 3, or the answer could be the negative square root of 9. And the negative square root of 9 we figured out was negative 3. So if you ever see that plus or minus sign, they want both answers. They want the positive answer and the negative answer. All right, so now that we went over that, pause this video and see if you can solve these 6 problems. All right, there's some negatives out there, there's some plus and minuses out there, and there's some regular square roots out there. So pause the video, see how you did. All right, how did you do? Check your work. Look at your paper, look at mine, fix any problems you might have. So this first one was negative square root of 81. That gave us negative 9. Negative square root of 1 is negative 1. Plus or minus the square root of 49 you can get 2 answers, 7 or negative 7. Because remember, it's looking for the positive square root and the negative square root. The square root of 225 is 15. The square root of 0 is 0, because 0 times 0 gives you 0. And plus or minus the square root of 100. And that, remember, whenever you see that plus or minus sign, you're going to have 2 answers. You're going to have the positive and the negative. All right, so that's perfect squares and square roots in a nutshell. If you ever have any questions, please feel free to ask your teacher. All right, also this week, we're also going to learn about the distributive property. Right, here I have an example using Legos. In this example, I have 3 groups of 2 plus 4. Well, I can see if I have this exact same thing that was earlier, 3 groups of 2 plus 4, I can see it's the exact same thing as 3 times 2 plus 3 times 4. If I counted up all my Legos, I would have the same amount. I have 1, 2, 3 groups of 2 and 1, 2, 3 groups of 4, just like I had over here. So the distributive property tells me I can take a number on the outside of the parentheses and distribute it to everything on the inside of the parentheses. So I could break this 3 groups of 2 plus 4 into 3 times 2 plus 3 times 4. And then I would use my order of operations. I know I have to multiply before I can add. So 3 times 2 would give me 6, and 3 times 4 would give me 12. And then I can add these two together. 6 plus 12 would give me 18. So I would have 18 little dots on my Lego. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that is the distributive property. The distributive property is saying if you have 3 groups of something in the parentheses, you can distribute it to each thing inside the parentheses. So we distributed the 3 to the groups of 2, and we distributed the 3 to the groups of 4. So here's the mathematical rule for the distributive property. We had A times the group or parentheses of B plus C. Sometimes you'll see this written as A next to the parentheses plus B times C, or B plus C. When something's next to the parentheses, that means multiply. Right? What we can do is we can distribute the thing on the outside to the things on the inside. So I can do A times B, which will give me AB, and I can also do A times C. A times C, which will give me AC. And then the addition comes down with it. So our answer for this would be AB plus AC. So using that in pre-algebra and algebra, what we can do for distributive properties, we take that first term and times it by the terms on the inside. So 2 times 4x, 2 times 4 is 8, and the x stays with it. And then we can also do 2 times 3. 2 times 3 gives me 6, so our final answer would be 8x plus 6. All right, that's distributed property in a nutshell. If you have any questions, please ask a teacher.